Video, we're going to look how to calculate pH, and we're also going to use the Henderson Hasselbach equation. So the first problem reads, find the pH of a solution with an H3O plus concentration of 3.5 times 10 to the negative 5. Now, first thing we need to do is understand what our equation for pH is. So, the equation for pH is equal to the negative log of the H3O plus concentration. Now this is a pretty simple, straightforward problem once you know the equation. So in this problem we are given the H3O plus concentration, which is 3.5 times 10 to the negative 5. So all we have to do is plug it in. So the pH is equal to the negative log of the H3O plus concentration, which is 3.5 times 10 to the negative 5. Plug this into your calculator and you get pH is equal to 4.5. That's your answer. Okay, next problem. Another pH problem. The problem reads, find the pH of a solution with an H3O plus concentration of 10.5 times 10 to the negative 8. Again, what's our equation for pH? pH is equal to the negative log of the H3O plus concentration. In this problem again, we are given the H3O plus concentration, which is 10.5 times 10 to the negative 8. So all we need to do is plug it in to our equation. So pH is equal to the negative log of the H3O plus concentration, which is 10.5 times 10 to the negative 8. Plug that into your calculator and you get pH is equal to 6.9. And that is your answer. Next problem reads, if the pOH of a solution is 5.5, calculate the pH of the solution. Okay, so for this equation, we need to understand the relationship with pH and pOH. So, pH plus pOH equals 14. So this is our equation. In this problem, we were given pOH, which is 5.5. and we were looking to find the pH. So simply we plug in what we have to our equation. So we don't know pH, so put pH plus, we're given the pOH, which is 5.5. pH plus 5.5 equals 14. Now to find pH, all you have to do is subtract 5.5 from both sides. And that gives us a pH of 8.5. And that is your answer. Now, is this pH basic or acidic? Now, since it's larger than 7, this pH is basic. Anything less than 7 would be acidic. Okay, just like the problem above, except this time we're calculating the pOH. So, if the pH of a solution is 7.5, calculate the pOH of the solution. So we start with our equation. So the pH plus pOH should equal 14. We're given pH, which is 7.5. We need to find the pOH. Same as the last problem, we subtract 7.5 from both sides, and that gives us a pH of 6, or excuse me, pOH of 6.5. That is your answer, and since it is less than 7, this is acidic. Okay, now here's where we're going to start using the Henderson Hasselbach equation. This problem reads, calculate the pH of the following buffer solution. We are given 0.050 moles of HC7H5O2, which is our acid. You know this because we have a hydrogen. We are given 0.150 moles of NaC7H5O2, which is our base. Our Ka is 6.5 times 10 to the negative 5. Okay, so for the Henderson-Hasselbach equation, it reads the pH is equal to the pKa plus the log of the base over the acid. So, in this problem we're given the Ka. We need to find the pKa. To find the pKa, all you need to do is take the negative log of the Ka. So, negative log of 6.5 times 10 to the negative 5 is equal to 4.2, which is our pKa now. So, from here, we just plug in what we have. The pH is equal to 4.2 plus the log of our base, which is 0.150, over the acid, which is 0.050. So that from there we get pH is equal to 4.2 plus 0.477, which gives us a pH equal to 4.67, or round it up to 4.7. That's your answer. Okay. This one reads, buffer pH changes through the addition of a strong acid or a strong base. The pKa given is 4.19. Our starting concentration of acid is 0.100 moles, and we have 0.100 moles of base. We need to find the pH after the addition of 0.025 moles of acid. Okay, so first start off with what we're given. Given 0.100 moles of the acid. We're also given 0.100 moles of the base. Now, we're adding 0.025 moles of acid. So you add 0.025 moles. And that gives our new acid amount to be 0.125. Now, since we're adding an acid, the base we need to take away from. So we subtract 0.025 moles, which gives us a new amount of base being 0.075. There. Okay. Now we use the Henderson Hasselbach equation. So we have the pH is equal to the pKa, which we have is 4.19, plus the log of the base over the acid. Now, our base was 0.075 because we had to subtract the 0.025 moles from it. So 0.075 for our base. Our acid, new acid is now 0.125. And this gives us pH equal to 4.19 plus negative 0.222, which gives us a pH equal to 3.97. That is your answer. Okay, now in the previous problem, we added acid, 0.025 moles of acid. Now we're adding a base. So let's start off with what we had from our previous. Our starting concentrations were 0.100 moles of acid and 0.100 moles of our base. Okay, this time we're adding 0.025 moles of base, which would give us a new concentration of 0.125 moles. In the previous problem, we added we've added acid, so we had to subtract base from the base. Now we are adding the base, so we have to subtract from the acid. So we would subtract 0.025 from the initial concentration of 0.100 moles of acid, which gives us a new concentration of 0.075. Now, we can use the Henderson Hasselbach equation once again. So, our pKa, which was given above, is equal to 4.19. So our equation would read the pH is equal to the pKa, 4.19, plus the log of the base over the acid. So our new base is 0.125, and our new acid concentration is 0.075. You plug that in, and you get pH is equal to 4.19 plus the log of 0.125 divided by 0.075, which would be 0.222. So instead of a negative, now we have a positive. So the pH now equal 4.41. Okay, so a recap. Our first problem, we're using the Henderson Hasselbach equation. We have the starting concentration of 0.100 moles for our acid and our base. If you're adding acid, you subtract whatever you're adding from the base and you add that to the acid. And vice versa, if you're adding a base, you subtract from the acid and add to the base. From there, you just plug in your new concentrations you have